Hello, everybody. You all enjoying the conference so far? Yeah. Oh, wow. Okay, let's try this again. I know I'm standing between you and drinks. So are you all enjoying the conference? There we go. All right, now we have something going on. So today, I'd like to start out a little bit by talking to you a little history lesson, if you will, about the telephone. This is Alexander Graham Bell, the picture you see here, and he is the inventor of what we would call the telephone. When he first invented it, it was primarily a point-to-point communication where you had to have two lines hooked together. But in order to really scale that and get to the point where multiple humans could talk to multiple humans at a given point in time, they had to actually make some level of interconnection or points of intersect. And in doing that, they formulated this idea of the operator. And so if I wanted to make a telephone call, I would actually ring up, not the person I wanted to talk to, but I would actually call an operator and tell that operator that I wanted to talk to somebody, and then she would then connect me. And the further the call that I wanted to make, the more operators I had to talk to in order to get there. But even at that, this didn't actually quite scale very well either. And so we actually had to move away from the manual aspect of a human interfacing and actually move to a more mechanical, in this case, is what you see here, but even beyond that, to a digital interconnection, where now all of a sudden everything is routed kind of automatically across the interwebs of space and time. But that was kind of the evolution of the telephone in order to kind of bring you to modern day communications. And if you think about the way that we've built applications and how we've actually interconnected them, we're actually taking a very similar journey. So if you think about it, back in the day with the client and the server idea, some of us had mainframes. I remember mainframes. But we had that connection of a very simplistic kind of client-server mentality. Right, where I had a front end and it was very simple for me to route traffic to that monolithic service that I had running kind of out there in space. Everything was self-contained, everything was right with the world. But then we started to scale this up, very similar like a telephone. We started to add more services, and we started to add virtualization, and we started to add physical switching, virtual switching, physical firewalls, virtual firewalls, all these different components in order to try to scale up the size and scope of the applications that we were trying to use to interface or communicate with others. And it all comes down to this simple thing, this simple idea. The identity of everything that runs on this network is connected to this simple 4 octets. Think about everything you have, every device. In fact, we've actually, there's a crisis brewing where we're actually outstripping this idea and moving to IVP6 just because so many IP addresses actually exist out there. And what this IP address or what this represents is actually created is a tight coupling between applications and the underlying physical infrastructure that it interfaces with. Think about decisions that are made when you deploy an application, and think about all of the dependencies around the network that go into it. The idea of networking microsegmentation, the idea of firewalling, the idea of load balancing, and we're going to talk about that here in a little bit, but this nomenclature of the identity of your service being tightly coupled to IPs is actually slowing down your ability to not only innovate internally, but to move to that idea of a hybrid cloud or a multi-cloud operating model. So I'm going to kind of ask a question, and we're going to kind of go through this. But in order to really start to think about this idea of demystifying a service mesh, you have to actually look at the problem and ask a controversial question, if you will. And I know there will be thoughts and the puzzle looks, but you have to ask this question. What if there was no IP? What if you did not have access to an IP? So I'm Steve, and we're going to kind of drive through this a little bit. This is the obligatory self-promotion slide. This is my Twitter handle. Feel free to get on it right now if you want to and tweet at me. I won't be able to answer until later, but you can at least make comments or anything of that nature as we kind of go through this. But as we kind of walk through and explore this kind of thought exercise of what if there was no IP, you have to start to kind of ask yourself some fundamental questions about how I would actually architect and deliver applications. The first thing is how would services be able to find each other if they did not have this identity nomenclature of an IP address? Or how would services actually be able to securely connect to each other? And in that context, then, how do I start to do the normal things around traffic shaping for critical ideas of deployment strategies, update strategies, failures, those types of things? So as we walk through these questions and look at it, I want you to kind of look at it and judge these answers by this criteria. That the first thing is that whatever you decide to do, it has to be able to further or bring a higher level of portability to your application delivery. Be it running on-prem, be it running in the cloud, be it running in another data center, it doesn't matter. You need to bring a level where I don't care where that service runs. The next thing is a higher level of agility. I want to be able to update immediately. Not just every day, but at will. I also want to be able to somehow lower my overall operational burden. This idea of the cognitive burden. I don't want to have to think as much about how I'm actually delivering and managing the intercommunication of all these services as I'm delivering them faster, and I have no idea where they're actually landing. And I want to be able to do that at an extremely low security risk, if at all possible. Now, I know you guys are asking, we've solved this, right? We've solved this with DNS. Okay, we haven't. That's okay. There are others out there that would say we have actually solved it, and it's with this. Now, there would be some people out there who might disagree. So let's start to explore these questions a little bit, right? The first thing is, how are services going to be able to find each other? This is foundational to even beginning to break apart this idea of a service mesh. This is the dirty little secret that you typically won't hear being talked about when you hear the buzzword of service mesh. You normally hear the mutual TLS connections and you hear about circuit breaking. No one's really coming in going, hey, services finding each other is really a core critical component, because they have assumed that you've solved it. And ultimately, this is the expression in human language that you're trying to do. Web app needs to talk to order processing, or needs to find order processing. Now, when we go through this is kind of what it would look like in a very simplistic idea, right? I have a load balancer in front of my different versions of my services or multiple copies of the service running. I've assigned a VIP to that load balancer to give it some level of static identity. Remember back to that idea of an IP, right? And then I've hooked those together with other components, be it load balancer, switches, routers, networking, whatever that may be above it. But ultimately, I've given it a DNS entry of webapp.internal or an order processing.internal, and they're able to communicate in that capacity. So by having this load balancer, I'm getting some level of assurance of things around the idea of request balancing. So in the event that I don't actually flood my services, I also am able to handle any type of failure and failover within this. I'm able to allow traffic to be routed to healthy nodes. And what I've done here is really I've added a layer of abstraction. I put a virtual IP at the load balancer, the entry point, and then underneath it, I've allowed those individual components to have their own IP addresses of any nature. But I can still find it. But what this creates now is this creates two different teams that now have to communicate simultaneously together. In this construct of a networking team, and in this case, the application team. So this is this is kind of group therapy. So if some of you start to feel a little anxious, that's okay. There are others next to you that are going to feel the same way. In this construct of I have an application team. They're going to deploy a new application, order history, and it's out. I've done it, and they've told the network team that's now been deployed. The network team will say, thank you very much. I've received your ticket. You will hear back with us within 72 hours, give or take. And then they go around and they configure a load balancer to go in front of it, and then the networking team will then call back to the application team and say, your traffic pattern has now been configured. Now, for some of you in this room, that may be I submit a ticket and I can take a week's vacation because that's how long it'll take for traffic to get routed back to me. This is probably how it's done. We'll just do a quick poll. How many of this is feeling a little too like reality? Okay, there's several hands there. Okay, good. Okay, so I'm kind of on base here. That makes me feel good. Now, some of us may say, okay, we've solved this problem, right? We actually have a solution to solve this issue. Okay? I mean, everyone knows this word. In some corners, this may be a dirty word. But we all see this and we think that this is what's going to solve it. And to an extent, it does, right? It has built-in service discovery. It has built-in load balancers. It has built-in internal networking. So in essence, yes, I could see how this would solve a lot of challenges because it has all the things. You're saying, see, this answers those questions that you posed. But when you really go to bolt this in, it doesn't take the place of it. It just becomes an extension of what you already have. Because you still have applications that sit out here on the bottom, and now what you've done is you've actually deployed a mobile access service. You've deployed a load balancer in front of that, right? An ingress controller, egress controller. You then hook it to load balancers in front of it in order for it to be able to find everything. And again, it has a VIP that is now a DNS for entry and exit. And so the same pattern happens. I deploy my Kubernetes cluster, I deploy my application. All right, now I've deployed the traffic pattern externally so that services can either route to it or services inside can route externally. Now, in a construct, and that's really where console comes in, and okay, I'll be fair, I'm a little biased, right? But I would probably agree with this even if I didn't work for HashiCorp. When you look at this construct of console, it actually makes things a lot more simplistic because I'm not concerned with an IP address anymore. What happens here is that when I go and I actually deploy my order history, under the covers, console is automatically converting that to some type of discoverable route in a nomenclature that's easy to be able to locate. And this construct is service discovery. And I cannot stress this enough. If you do not get service discovery right, there is no reason for you to do a service mesh. You must do this portion correctly, or your service mesh implementations will not go very well. Now, if you think about it, when you're running these service meshes, you're thinking about Kubernetes, you're using that service discovery, but you have to find some way to expose that service discovery, to register services externally. It becomes very challenging. And this construct with console becomes very snap-in, very easy. It's something that's understood both inside of the world of Kubernetes and containers, and externally in the world of bare metal, in the world of even mainframes, you can do that as well. So this allows you to span across and do service discovery very well in that nomenclature. And here's an example. Again, it's very simple, something everything understands. I mean, even my toaster at home understands doing DNS lookups. So the next question we have to kind of move on and actually begin to communicate with is this idea of how can services now securely connect to each other? I've solved this challenge of service discovery, that's great. But now how do I move in, and why do I want to move into this idea of securely connecting to each of these? So let's go back to our example before of web app wants to talk to order history, but not only do I want it to talk to it, I want to ensure that it's talking to it securely. And I want to ensure that only web app can talk to order history. If we're going to decouple the IP, this is the next step. There is a high burden within the networking organization that they're not only just managing pure network security, they're actually managing application security at the networking level. If you think about the conversations that you've had around microsegmentation at the IP level, and firewalling and those types of things. They're bringing a high level of network of complexity to the network, and they're actually unable to optimize networks effectively. And that's why it's actually very slow for them to make changes, because they're not only having to worry about general network security, which they absolutely should be concerned with, but they also have to be highly concerned with application security flowing across that network link. So let's go back to our example, right? App team, network team, but now we've added a new team. We've added a third group here. On the far right side here, you can see we have the firewall team. So now what I've done to actually ensure network security is I put a bunch of firewalls in front of everything. Now I'm hearing some laughter from this side, and I think they're laughing because if they didn't, they would actually start crying, because this is exactly how it looks in their environment. So now I have firewalls in front of my applications that ensure that those application components can only talk to the load balancer. I have firewalls in front of the load balancer to ensure that they can only talk to other load balancers in front of them. And then I have to put a firewall in front of my Kubernetes cluster to ensure that I can route traffic and protect traffic going in and out of that ingress-egress point. I was talking to a regional bank recently, and they told me that when you go to log in to their online banking, you actually traverse 50 firewalls just in the login process. And then you wonder, why can't the network team do an upgrade to the latest firmware updates, or how can they keep up? Because these are the types of complexities, right? We've grown, we've added more operators to the equation. So now this is how it works. This is how the conversation goes. App team says, hey, I've deployed order history. Network team says, thank you very much. We'll get back to you sometime. Networking team then contacts the firewall and says, hey, they put this out here. We really can't configure the load balancers until you configure the firewalls. So then the firewall team has to go through and parse through their 2 million row Excel spreadsheet in order to validate everything, and then they contact the network team and say, we think we got it right, it does sound like it works. Then the networking team makes their load balancer adjustments, and then they communicate back to the app team and say the traffic pattern is configured. Now, I talked to a customer 2 weeks ago, and they told me that this process takes them anywhere between 30 and 60 days. Folks, once you solve the provisioning problem with Terraform, your next step is immediately moving into this realm of dealing with service discovery and ultimately moving to this idea of service mesh, because it is going to be the next bottleneck in your deployment workflows that are going to cause you the greatest queue times. And let's not forget that on top of this, we're adding all of this fun stuff. So now I've got multiple clouds, and they express networking entirely differently than anybody else. AWS expresses it with all kinds of different connectivity nomenclatures. GCP expresses it differently. Azure expresses it differently than that. And don't get me wrong, Terraform does a fantastic job of configuring and managing these things. But a lot of times we're building complexity into our Terraform code, all in an effort to maintain that level of network security. Think about all the routing, all the firewall rules, all the security groups. We're inherently copying and pasting these operating models within our private data center and moving them to the cloud. So now, if we add the cloud, everyone following the theme here? We're all moving together, right? We're just adding more players to this group. App team now calls the cloud team, says I've deployed. Cloud team then calls the network team, says, hey, we've added a new service and it's out in GCP. Network team says, great. Now we go to and the cloud team comes back and says, all right, we've configured our part. Network team's still going to do their part. They're going to get back to you. Networking team does their firewall rules and everything else, comes back to the network team. Network team then talks to the cloud team and also does talk to the app team and finally says, traffic pattern configured. I've had customers tell me that sometimes this can take anywhere up to 3 months. Tell me, where are we getting the speed? We're moving closer and closer to this idea. I don't know about you, but this scares me. So let's actually move into this idea of how do we actually secure applications if there is no IP. And let's, again, I'm going to be biased. You are at HashiConf. We are going to talk about console here. But let's just kind of look at this idea of how, once we solve service discovery, how a service mesh comes into play in this context. And so now I have console running. And within console, we have some constructs of intentions. We have a certificate management. And we also have ACLs. What ACLs do is it actually gives you a way of applications to get some level of identity that is not IP-based. I can give an application an ACL token. I can utilize Vault to actually generate that token based off of some type of authenticating machine identity. Once I have that ACL token, that machine has an identity, it can then be mapped to an intention. And what that intention actually says is web app is allowed to talk to order history. Now what happens is that we use our favorite proxy. Everyone knows Envoy. I don't need to really go into too much detail of what Envoy does for the most part. But the big key here is that because of the service discovery capabilities within console, and because of the ability to have a distributed key value store, that means that I can basically manage centrally in a data plane and be able to deploy to Envoy and dynamically configure it on the fly. So that intention then translates and says, this is the configuration for web app Envoy proxy. This is the configuration for order history Envoy proxy. And then what happens is that a certificate is then dynamically generated that is mutually signed between web app and order history. So that when web app talks to order history, it's now talking over a private tunnel. And so in the context of a web app, what it actually says, instead of trying to hit order history.service.console or order history.mydomain.internal, whatever it might be, and I have to manage the port range of 1531 or 9000 or anything of that nature, localhost the application can simply talk to localhost on any port. On the order history side, you can maintain default ports because the communication traffic is now running at a non-privileged level between 20,000 and 22,000. Now you can go to your network team and say, the only thing I care about is that bits can flow from A to B on this port range of 20 to 22,000. I have offloaded all of the application security and communication bits and put them into the application configuration. I'm actually baking security in to my deployment pipeline. And if any of you have read any of the DevOps handbooks or the Phoenix project or anything of that nature, that is exactly what they tell you to do. That security must be baked in to the application deployment pipeline. Here's what it looks like. It's a very simple artifact. Not only in that, within console enterprise, we also are bringing to bear the ability for you to be able to maintain a level of consistency from a security model perspective, where you can actually comb through these and ensure that you can ensure that certain policies, global policies, would be enacted and configured. Now, these can be checked into version control. Changes, this is the big thing here, is that change is now a PR request. And so in that construct, my documentation updates as a matter of the change being implemented. So instead of me changing some type of communication and then having to go back and document it, and I know nobody in this room is guilty of that. Nobody here has ever done that. But now, simply by making the change in the environment, the output is the documentation of what the environment is. Think of it like dynamic CMDB type stuff. So now if we go back to our same situation, right? I have web app, I have order history, I have all these different things. I now have federated data centers with console, and I have all these different services that can talk to each other. But hey, I'm adding the cloud in here. We can't forget the cloud. So now I have the cloud in here, and I have services running in AWS, and you saw the announcement from Azure, you're gonna have a managed console within Azure, and you can hook that right into your console on-prem. And so now I have all this stuff, and we have all the secure communication, and then you go, wait a minute, the nightmare scenario, if I go to my networking team and talk about it, is that this is what it's gonna look like. They are not gonna like this. It sounds in theory great, but this is not a scenario that people are gonna be happy about. And we thought about that. We thought very long and hard about how we would go about solving this particular challenge. And so we came up with something very kind of elegant in nature and simplistic, but makes a lot of sense. So what we actually have done now is that we've created this idea of a mesh gateway. And now these mesh gateways sit in front of your services between data centers. And so what happens is that the applications actually talk to these mesh gateways, and then the gateways forward the traffic appropriately. So now in these multi-center gateways, I can define. For instance, I can say traffic can only stay in my local data center. It actually can't escape. Think of this as being maybe a default service policy with the tag of dev. So dev instances can never reach outside of their local data center that they're spun up in. Or here, I'm actually opening this up. This may be a prod configuration. If you look where it says Mesh Gateway, it's saying remote, allowing me to say I can communicate externally or I can communicate remotely. And so the last question here kind of becomes more of a benefit than it really is a challenge. And that is, how do I programmatically do traffic shaping based on changes in strategy? We heard earlier today, Mitchell talked about here on main stage, about this idea of I acquire somebody else, right? We've acquired another company. How do I wrangle and bring them in? How do I manage any type of updating, rolling updates, and failure? Well, in this context here, you can see that can be kind of challenging. That can be kind of tough. But if we look at it in this context here, this is what you're trying to do from the traffic routing perspective. I'm trying to say I have a web app, a certain URI endpoint points to a specific service. Now, the beauty of wanting to go down this route of being able to kind of shape based on any type of HTTP parameter is I can take my big, ugly Java monolithic application, which I know everyone out here has. It's okay. I know you have it. I've had them. They're out there. And I can begin to peel them off by URI callout and kind of splay them out over microservices over time versus having to say, okay, I got to break this all apart in one shot to get it out there. I also want to be able to do some level of traffic shaping so that I can iterate faster. Remember, we want to move more agile in this. And I also want to be able to handle some type of failover. What happens in the context of order history is no longer available. Well, in this context of having the mesh gateway and having all the interconnectivity between this, now I can actually handle not only HTTP traffic routing. So think about it in this context. I take a service, I peel it off, I place it in maybe GKE or AKS or something of that nature, and I put it at the /endpoint admin. When I have a service mesh in place, something like console, when my front end actually hits that endpoint, it will be routed dynamically over my mesh gateway securely into the cloud, into my Kubernetes cluster, and actually be processed. What if I want to move it the next day because of whatever reason? Maybe I want to iterate again and bring it to my second version, or I have some type of failure and I want to move it to GCP. Just by simply it coming online, because again, I've solved that service discovery problem. When that service comes back online again, wherever it is, it will be able to be found. And as long as traffic and bits can route from A to B, I'll be able to actually service that request. And again, super simple, super human readable. It's documented right here within the code base. This is auditable. It's static, meaning I can comb through it. I can look for any type of errors. I can validate that specific security permissions are being honored. And a great aspect of this is now the developer has access to actually define this. So the developer can define this. It can be reviewed and it can be checked in. And what I start to do now is I start to break apart that IP. If we look back, now console becomes that disintermediating layer, allowing the network teams to move effectively and efficiently, right? So now they can actually have more optimized networks for general security practice, but also for a higher level of throughput. Now they can do those upgrades. They can do those firmware updates because their concern is not as much about maintaining application security as it is about maintaining general good networking security practices. And on top of that, optimizing the network for overall throughput. And the application teams, they're not encumbered by waiting for the networking teams to do all the application security mappings because that's now all been offloaded into the application space. And so when we look at this in a development pipeline, in development as an application developer delivering services, when my application lands in development, because it's talking to a local host, everything about where it's landed is defined by the underlying system. So environmental configuration, secure access controls, network optimization, all those things are defined, but yet abstracted away. So as this moves across your pipeline, the application picks those up and inherits those from the environment in which it runs in. So no longer am I worrying about development instances accidentally talking to production databases. I'm sure nothing like that's happened to anybody in this room. Right? Or worse yet, having some type of production instances talking to development instances. Because I actually have baked that off as just an artifact of where I land. So in closing, if you think about this, just like we've kind of modernized and moved from the old pick up the phone, and actually, if you look at this phone here on the left-hand side, it actually doesn't even have a rotary dial. To where we are in this kind of modern take on telecommunications, in order for us to really begin to move forward in adoption of service mesh, move forward in this really adoption of kind of next-gen networking implementations, we're really going to have to start peeling away this tight coupling against the IP. So a couple takeaways. This is where you might want to get out your phone. When you go home, you want to call up friends or bosses or discuss this with your wife tonight on the phone. You laugh, but my wife actually, she's heard this presentation like 6 times. She actually understands service mesh now, which is great. Because when I say it, she goes, well, at least I know what you're talking about when I hear you on the phone. So first takeaway here is to do service mesh right, you need to start with the right premise, the right philosophy, the right idea. Now I know I can't say no IP ever because then you go, well, how are we going to get traffic routing and TCP is very important. I get all that. But it's more of a philosophy, right? I have to act as if I don't have access to it. Let's start from that premise and work from that particular constraint. The next thing is service discovery is table stakes in this shift. Do you see me after? You ask a question. My first question to you is going to be, how are you solving your service discovery challenge? You must solve this first. Absolutely, must solve this first. You must also have that measure the ideas based on agility, portability, and resiliency. How fast can I move? My breadth of where I can actually move to, and how can I take a hit and keep on moving forward? And look, console's awesome. If you haven't tried it, you should go check it out. This is actually, there's a ton of stuff down on in the hub. Also, real quickly, if you're going to be here tomorrow, find Nick Jackson's presentation, because he's actually going to use the examples that we talked about in this talk and actually go into the nuts and bolts of how it actually works and how you do it. So if you want to kind of get, like you've seen, oh, the house looks built, this is really pretty, but I want to actually understand how I cut the wood and put the nails in. He's actually going to go really, really deep. So he's not going to talk a whole lot about what we've talked about here. He's going to jump right into kind of the nuts and bolts of how do I stand this up, how do I get it working, and how does it actually look. Thank you, everybody. I really appreciate your time. I hope you found this informative. Thank you. Thank you very much.